Okay, this one's a little bit more interesting. We have parallelogram ABCD. BE is perpendicular to DC, right? So then BF is perpendicular to AD. So we should immediately think something's a right angle. This is the other right angle, and then these two things are congruent. Right? These are the next two steps, and then we should focus on what they want us to prove. So BAF is this right here. They want this to be similar to BCE somehow, right? So we want two angles in these two. So first thing, it's a parallelogram, opposite angles are congruent. There's one right there. Second thing is that BE is perpendicular to CD, so that's a right angle, and then BF perpendicular to AD, so that's a right angle. They didn't draw it to scale, right? You shouldn't expect them to draw it to scale, but here, we have two angles. So let's write this out. So then I'll say those two right angles, I'll do them first. So I'll say angle BFA is a right angle. And then I'll also say angle BEC is a right angle because perpendicular lines form right angles. Right. And then I'll say that's the same thing for this one. And then I'll say angle A is congruent to angle C because in a parallelogram, opposite sides, opposite angles are congruent. And then that's it, actually. So triangle BAF is similar to triangle BCE because angle. Simple as that. As long as you can figure out which two triangles you need, and then you can find two angles that are congruent, that's the whole proof. Okay, next one, also interesting. We have triangle JKL. KM is perpendicular to JL, JK is perpendicular to KL. And focused on this, JKL, similar, this larger triangle, similar to KML, this smaller triangle here. Right, so they share an angle, so that's a freebie, right? And then these perpendicular stuff, that's probably our second angle. So KM is perpendicular to JL, so that's this right here, and then JK is perpendicular to KL, so that's this right here. Again, I usually try to split these apart so it's more obvious. This stays. This goes here. Right. So, yeah, let's write this out. So we have angle. We'll do the right angles first. We have angle JKL is a right angle, and then I have angle KML is a right angle. This is because perpendicular lines form right angles. Same for both. And then I can say angle JKL is congruent to angle KML because all right angles are congruent. And then I can say angle L is congruent to itself. It's congruent to angle L because reflexive postulate. And then we can say the proof, which is triangle JKL, is similar to triangle KML. And that's angle. That's it. Okay, I realized I made a mistake. Here I forgot to write that angle BFA is congruent to angle BEC, right? Because all right angles are congruent. I always want to double check. Okay, so yeah, make sure that we have two angles congruent to each other. Okay, so this last one, number 5, so let's see this. We have parallelogram ABCD, diagonal BD, and yeah, they intersect. And we want to show BML, this triangle right here, is similar to DMK, right? So we have these two are vertical, so they're congruent already. This is part of a parallelogram, so these two sides are parallel, and then this is a transversal, which connects these two. So then this angle should be congruent to this angle. We can also do this one with this one. Yeah, there's a bunch to choose from. So yeah, let's write this out. So can say, I'll do the vertical ones first. LMB is congruent to angle DMK because vertical angles are congruent. And then I can say, I have to state that the lines, opposite sides are parallel. So we can say BC is parallel to AD because opposite sides of a parallelogram are parallel. And then I can say angle C, okay, angle C, CBM is congruent to angle MDK because in okay, because in a pair of parallel lines, alternate interior angles are congruent. Okay, almost done. So we have two angles now. Now we can say the proof that they want triangle BML is similar to triangle DMK because angle. That is it.